Okay, next on our list of concepts to be studied is the trigonometric functions of any angle. And basically what that means is every angle exists in the coordinate plane, and we've briefly touched on this when we talked about just radian measures and degree measures, and how if you move in a counterclockwise direction, then you're moving in the positive direction, and if you move in the clockwise direction, then you're moving in the negative direction. So all angles exist in the plane. If their vertex lies at the origin, then you have an angle in standard position. And that angle is formed by rotation of a certain degree measure. So if I move in the counterclockwise direction, then I'm going to have a positive angle, and it's going to exist somewhere within the plane with my terminal side, where the side that lies on the x-axis is the initial side, and the side where your angle stops its rotation is referred to as the terminal side. We talked about how you have coterminal angles, where in addition to this angle, we also have a coterminal angle that goes in the opposite direction that will share the terminal side. But another concept that you need to be familiar with is what we refer to as a reference angle. Your reference angle is always going to complete your rotation to the x-axis. So for this angle, my reference angle is going to live here. Okay, so theta in this case, if I call this angle theta and I call this angle beta, theta would be the reference angle to angle beta, because it is the angle that completes my rotation to the x-axis. Your reference angle is always going to be less than 90 degrees. It will always be an acute angle. And your reference angle doesn't have direction, so you don't have to worry about positive or negative. You're just using it in relation to how far away from the x-axis am I. Now that becomes important whenever we talk about points in the coordinate plane. So what happens in the coordinate plane whenever I have a point, if I use the point for 5 in the coordinate plane. So we'll say that P exists at the point 4, 5. Well, I know how to plot that. I'm going to come over 4 units, and I'm going to come up 5 units, and I'm going to plot my point. Well, in addition to this point existing here at 4, 5, there is also this ray that exists here at 4, 5. Okay, and if you go on to pre-calculus or calculus, then you'll talk about vectors. Well, this is a vector, and what a vector does is it establishes a direction from the origin to the point. And anytime that happens, you create an angle on the x-axis, where the x-axis becomes your initial side, and your rotation to your point in order to create the point is your angle theta. Now, if you drop a perpendicular to your x-axis, your angle theta is always going to live right here at the origin. So no matter where it exists in the plane, it's always going to be based at the origin. And when you drop the perpendicular from your point to the x-axis, then you create this right triangle. And we know how to work with right triangles because we know the Pythagorean theorem and we know our trig functions. So from here, we know that this side length is going to be 4. It's our x coordinate of our point. And we know that this side length is going to be 5. That's our y coordinate of this point. So I can find everything from the hypotenuse of the triangle. I can find the angle that created the point of the triangle, all just from the pieces of information that are given to me here. So, as an example, we are going to let point P exist at -3, -5. And that point exists on the terminal side of theta. And we are going to find each of the 6 trig functions as ratios. Now, from yesterday, we talked about sine, cosine, and tangent, and then I also gave you the reciprocal functions of cosecant, secant, and cotangent. So just simply graphing this in the plane, if we are at -3, -5, that means we are going to exist, we're going to come 1, 2, -3, and down 1, 2, 3, 4, 5. So we're going to exist here in our third quadrant. Remember, your quadrants go 1, 2, 3, 4. So we exist here in our third quadrant. And if I drop a perpendicular, and by drop I mean go up because we're always going to the x-axis, then our theta exists here at the origin. And we know that our side lengths are going to be -3, -5. So, in order to find my 6 trig functions, then I'm going to need to know my hypotenuse. So to find my hypotenuse, I use the Pythagorean theorem. So I'm going to have, if I call this x, or I won't call it x so it's not confused, we'll call this a. So I have a squared is equal to -3 squared as my x coordinate plus -5 squared as my y coordinate. And so we have a squared is equal to 9 plus 25. Well, 9 and 25 are going to add together to give me 34. So I have a squared is equal to 34. And when I take the square root of both sides, I'm going to have the square root of 34. Okay, and since we're talking about a length, we know that length can't be negative. So at this point, we're going to keep just the positive value of the square root of 34. So when we're here, I use this value for a as my hypotenuse in order to write all 6 of the trig functions for my theta. So I know that sine of theta is going to be the opposite over the hypotenuse. Well, opposite theta is -5. So I have -5 over the square root of 34. But I can't leave 34 in the square root of 34 in the denominator. I have to rationalize it. So I'm going to multiply the top and the bottom by my radical. And this is going to give me -5 square root of 34 over 34. I find cosine of theta in a very similar way. This is going to be the adjacent over the hypotenuse. So I take -3 over the square root of 34. And then I have to rationalize the denominator the same way I did for sine. And this is going to give me -3 square root of 34 over 34. And then when I find the tangent of theta, well, tangent is going to be the opposite over the adjacent. And so we're going to have -5 over -3, but a negative divided by a negative is a positive. So I have 5 over 3. And then you also have your reciprocal functions. So